Welcome to Securing Digitalization, the Siemens Cybersecurity Podcast. Cybersecurity is all about deception. People impersonating other people, machines pretending they have access rights which they don't have. What's changing is technology, the tech we use. And at the moment, we have a lot of new tech developments. Of course, the most prominent, artificial intelligence. And I will talk about that, the new opportunities for attackers and defenders with artificial intelligence. And I have with me to talk about that Andreas Kind. He's the Vice President for Cybersecurity and Trust at Siemens AG. Hi, Andreas.
Hi, Andreas.
Now, future technologies. At the moment, of course, everybody's talking about ChatGPT, artificial intelligence. That's the big one, but it's not immediately obvious. What's the connection between artificial intelligence, generative AI, and cybersecurity?
Yeah, indeed. Everybody talks about large language models, ChatGPT. It's a big topic. And the question is a good one. So what is the relationship between cybersecurity and artificial intelligence? And there are really four different ways of looking at this relation. The first one is you can actually use AI to attack. And this can be done by cybercriminals. They may use AI to be much more efficient, to be more accurate in terms of the way they use deception. But AI can also be used by the good people, if you wish, for doing penetration tests. So that's the first relation. The second one is that AI can also be used to defend against traditional attacks, but also against other AI-based attacks. So in this case, we really have a head-to-head race between the good guys and the bad guys. Then the third relationship is that an attack can be targeted to AI. And again, it can be done by cyber criminals, but it can also be done by penetration testers to find out where are the holes, where are the vulnerabilities. And the last obvious step is then how can AI be protected? And this is typically a topic for developers and for product owners.
We often talk about cyber war, and it's not just an image or an allegorical use of the term. It is a war, it's a fight. And in a way with AI, both attackers and those who want to defend themselves have something like an army of digital robots at their disposal that they can send into the cyber war.
Mm-hmm. Yeah. So in this first topic, AI used to attack, and of course we don't talk here about the eventually fateful moment when AI surpasses our intelligence and it takes over the world, so to speak. But we talk about the vulnerabilities. There is a pretty good list of the known vulnerabilities of AI systems that is provided by the Open Worldwide Application Security Project. And the first one on this list is really prompt injection. And maybe you have tried this yourself as well, that you use ChatGPT, you typed in some questions, some information, and you tried to game the system with some crafty inputs. And
can you give an example? What would be a crafty input?
You can provide information that where initially the system would tell you not to, that this information cannot be provided. So let's take a cybersecurity example. So you could actually ask the system to write you a code to do an attack on a system, on a software system. And the system would first try to prevent giving out this information. But if you turn it around and basically turn the system into a teaching system that should tell you how to prevent that these attacks happen, you can actually turn it around and then get the information out of the AI system. So the second one on this list is the insecure handling of information, in particular the information coming out of the system. That's in a way, standard cybersecurity, that you have to make sure that information that leaves a system is securely communicated to the person interacting with the system. The third one is then that the training data is poisoned, and that's happening quite a bit. So we do see attacks where the training data is manipulated, and then the results from prompting the system are different than expected.
So if we stay in the image of cyber warfare, the training data might be about, okay, this is how you get the red robots, but then you manipulate the data and train the system to go after the blue ones, and boom, suddenly you've lost your defense.
Just maybe to mention two more typical vulnerabilities on the list. There is also the typical denial of service attack to such an AI system, where people try to input very heavy statements or text that make the AI system unresponsive. And then a very critical one is also that in certain cases, it's possible to retrieve sensitive information. The system is typically trained with potentially sensitive information, so it might be possible that also the output provides such sensitive information.
One example that we've heard quite a few times, an employee at a large tech company decided to just record the board meeting. The person had to write the protocol of the meeting and decided, let me ask ChatGPT, can you sum it up? And ChatGPT provided a really good sum up of the protocol of the transcript of the board meeting. The only problem is it was highly sensitive information, and you just shouldn't feed it into an AI system which is not fully controlled by yourself.
Mm-hmm. Yeah, right. I think the problem is really that we have today so much information about what we do in the internet. So sometimes without even actively knowing or deliberately knowing, we surrender sensitive information, in particular when different sort of pieces of information are put together in order to create an image.
Let's get practical, Andreas. What would be a concrete example for cybercriminals using AI today as a tool for deception?
Yeah, let's look at such a scenario. So just imagine you are a lawyer in a young startup. You're quite sort of eager to support a very important business meeting that just happened with the contracts. Now you receive a phone call from the CEO right after the meeting. The voice doesn't sound to be very well, so it's breaking up. It's a noisy place, it seems. It's the CEO that is apparently in a busy area like an airport, and he's asking that you send the contracts again over a private email. And the reason is that apparently the business email doesn't work. So you then reply because you think it's urgent, it's important, to this private email address. And of course, this was not the right way to do, because in that moment you send the contracts actually to some cyber criminals.
But wait a second, it's the voice of the CEO, right? I mean, how is it the voice of the CEO if it's not the CEO?
Correct. It is the voice of the CEO, only that everything was crafted by a artificial intelligence system, including the creation of the voice. There was a system involved that could synthesize the voice such that you believe it's indeed the CEO.
So I might not even be speaking to Andreas Kind right now.
That could well be the case, yes.
Oof, okay, but I mean, what you have to say is so interesting. I mean, even if you're impersonating Andreas Kind, this is delightful. I'm learning so much. Now, this is how today we can already use AI to create impersonation, to decept, to impersonate individuals, humans. But the world is connecting also a lot of devices to the Internet of Things. We're adding connectivity to machines, to cars, to everyday objects. So what are the ways to use AI to decept when machines communicate?
Yeah, quite right. So the topic of deception is much broader. And you could actually argue cybersecurity is like football. Do you know Maradona's famous quote?
Tell me.
So football is the game of deception. And in the same way, you can say cybersecurity is the game of deception. And it's deception around identity. And we just had a case where we spoke about people's identity. But the concept of deception goes much broader. And here we can include also devices, which live in a digital space where you have technology also to create deception in this digital space, not only for people, but also for devices.
Can you give an example for that? Why would I, in the first place, try to impersonate or devise a device? Why would I want to deceive here?
Yeah, let me give you a scenario again. So think about a complex new commercial building that is shared by multiple organizations for work, for providing services, security services, cleaning services. It has a modern heating, cooling, ventilation, solar panels on the roof for charging EVs, light control, everything, all the jazz that you could think about when people talk about smart buildings. And this is enabled by devices that are typically delivered with a digital certificate to a manufacturer. And this certificate is what is called a birth certificate. And the difficulty is now when you think about a fitter in charge of installing the smart building devices, this person has typically is an expert in the physical installation. But if you would be now in this role of the person installing these devices, you might not know how to also configure these devices to have secure communication within the trust domain of the building operator.
So just to check in to see if I understand well, traditionally buildings weren't very smart, and it's just over the last 5 or 10 years that we put a lot of technology into buildings, a lot of connectivity, and whoever installs all these little devices may not, or is most likely not, an IT expert. So you have folks doing this who were not fully trained and clearly not trained in the intricacies of cybersecurity.
Correct. So, as I said, this person is an expert in physically installing these devices. But the fitter, and if you would be in this kind of role, you would probably not know how to provide the necessary credentials and configurations, security configurations, to have this device securely communicate in this trust domain of the building. And this brings really a lot of need for efficiency increase. So we talk about today that we have protocols, new protocols that allow these devices to automatically retrieve the respective credentials. And this would then save basically, if you would be in the position of the fitter, the time for installing these devices, but in addition also avoid the misconfigurations that today very often happen because people are simply not so knowledgeable in configuring these devices.
So cybersecurity in many ways is still only just growing up or coming of age. There's still the paradigm, the general idea that, well, yeah, with every device you make it cyber secure. There's a lot of manual work around that. No, this has to be automated because the weakest links are humans.
Correct. And this automation comes also because we see that the old way of secure infrastructures doesn't really work anymore. In the past, we thought about our infrastructures as being castles that are protected by firewalls. Today, this is no longer possible because we have home office, we have mergers and acquisitions where networks have to come together. We have much more partnering where it's difficult to say if somebody is within the infrastructure or outside the infrastructure. And the technology to secure today's infrastructure without thinking in this kind of castle way was called zero trust. So every access to a resource is verified. And because of this verification, we end up with a lot of data. And this gives us opportunities again.
I understand it a bit like a medieval city. That's the old way of doing things. You have your firewall, you say this is my network, and I build a big high wall around it. If you want in, you go to the main gate, and then you're in. But once you're in, you're in. You can access a lot of information. And the new world is you have almost an open gate. Anybody can come in, go out, but every single house, every single room in the village, every drawer has policemen, if you will, policewomen, police people who check your credentials. Are you allowed to go in here? Are you also allowed to go into this room at this time? Is it plausible that you should have access? And we do that hundreds, millions of times every single day.
Yeah, very, very right. So it's the concept of checking every access, every resource. It's not just from people to a device, to some databases, but it's also between devices itself. If you understand that because of this policy-based approach using Zero Trust, we end up with significantly amount of data about the patterns of access that happen within an organization. And this opens up opportunities for using AI again. So we actually come back to our 4 different relations between cybersecurity and artificial intelligence. So we can use in future AI to much better defend our critical infrastructures, our factories, our energy networks, because also these will be driven by Zero Trust operated access control.
So it's a bit like at any turn in history when new technology was around, it helped attackers, it helped defenders, it changed the rule of the game. And that's happening now. But it's not only AI, right? What would be other technologies we have to look at? We might not have the time to go so deep on them. What else is on the horizon, Andreas?
Yeah, we just talked so far very much about identity, deception, trust, and AI, how AI can be used in this kind of context. But we are facing in the cybersecurity space other challenges. Think about quantum computers. Very soon we will have regulation that comes up which demands that certain crypto schemes, particularly the asymmetric crypto schemes, have to be replaced with quantum safe crypto schemes. And here we have a lot of initiatives going on in Siemens to really go very quickly into the quantum safe era.
So a lot more work for you and the teams to do. I would love to talk more about that second topic in a future episode of this podcast. Andreas, thank you so much for your time. My avatar will be in touch with you with my hacked voice to follow up.
Okay, I'm looking forward to this. Thanks, Andreas.
Thank you, Andreas.